Comes out of section 10.1, area under a curve. So a very specific example, this time with numbers given. Find the area under this parabola y equals x squared plus 2 from x equals 3 to x equals 6. If I draw a little picture of that, a parabola that's here, and we're talking about from 3 to 6. What's the area of that region under there? Well, this time I don't have a rectangle and a triangle to draw because it's a curve on top. But what I can do is say, well, I know that the derivative of the area is x squared plus 2. So if I take the antiderivative of that, it's x cubed over 3 plus 2x plus c. Now if I evaluate that from 3 to 6, what I do is I say a of 6 minus a of 3. So I put in the 6 here. 2 times 6 plus c. And I subtract and put the 3 in here. What you'll see is that the c really doesn't matter in these questions. It kind of becomes irrelevant because you have c minus c. They cancel each other out each time you do one of these where you have the numbers. But we do end up with a number, a value here, where we have, this ended up being 84 plus c minus 15 plus c, which ends up giving you an area of 69 square units. We usually won't even bother writing in square units, but the area under that curve is 69. So let's try another example of that. Change the wording a tiny bit here to say find the area between y equals sine x and the x-axis from x equals pi over 4 to x equals pi over 2. Hopefully you have some recollection what a sine graph looks like. And pi over 4, somewhere around here, pi over 2 here, and we're saying what's the size of this area here. A much smaller little region shaded than what I had up there above. If I can answer of 69 for this one, I might be kind of surprised. But basically I know that a prime is equal to sine x. So the area function is equal to negative cos x. And I'll put the plus c just to stay in good habits. I know that the c is going to cancel out when I evaluate this, because what I'm going to do then is say, well, my area is a of pi over 2 minus a of pi over 4. And those c's will go away. So I'll have negative cos of pi over 2 plus c, but then I'll have minus negative cos of pi over 4 plus c, and I'll start ignoring those c's as I go in these. And negative cos of pi over 2 is 0, negative 0 is still 0. Now minus minus means plus, whatever cosine pi over 4 is, and hopefully you recall that that's root 2 over 2. So the answer to this question is, as I said, a much smaller number, is square root of 2 over 2, which is the size of that little region there. Just to introduce to you the different notation, I introduced it in the last example, but just a quick, for the question at the top, another way of asking this would be to say the integral from 3 to 6 of x squared plus 2 dx, and I would do basically this exact same work that I did here. Find the antiderivative and then substitute in the number. So here I could have written this question quite a bit shorter by saying from pi over 4 to pi over 2 sine x dx equals, and pardon me, you would do the exact same work that we just did here. Find the antiderivative, substitute in pi over 2, pi over 4, subtract, and find yourself your area, and you get root 2 over 2 as your answer.